Hello, this is Dennis. In this video, I'll unlock the secrets of the HOD UV. I'll uncover the key reasons why the HOD UV is more powerful and has stronger efficacy than traditional UV technologies.
Hydro-optic disinfection technology. Revolutionary science for water and wastewater treatment. The HOD UV has validations, references, and awards not seen by any other traditional UV technology. The Electric Power Research Institute awarded their 2019 Technology Transfer Award to Tracy Underwood and Aaron Nichols from Southern Company's Plant Bowen for their use of the HOD UV. The U.S. Bureau of Reclamation gave their 2019 Project of the Year award to their researchers based on multiple studies using the HOD UV. Power Magazine gave their one and only 2019 Power Water Award to the U.S. Bureau of Reclamation. I personally congratulate everyone on your award. The HOD UV is based on the sum of three sciences. The first science is a medium pressure polychromatic lamp that puts out a complete broad-based germicidal spectrum. Medium pressure lamps have the highest UV output at all temperature ranges. Low pressure lamps and low-high lamps are affected by temperature. The second science is internal reflection or IR technology that simulates fiber optics. The IR technology increases UV wavelength to recycle or concentrate the UV's energy. Without IR technology, the metal acts like a sponge and absorbs the energy. In an example, over 4 years, the U.S. Bureau of Reclamation studied the value of the HOD UV. At the most efficient pathway, which is the instrument level, the U.S. Bureau of Reclamation researchers determined Veliger inactivation at 100 millijoules per centimeter squared. Then, the researchers installed a traditional UV system at 100 millijoules that failed. With all its imperfections, the 100 millijoules was an average dose, meaning that half the time it worked and the other half it failed. It was elected to double up the size of the equipment and the lamps. At the much higher dose, the researchers achieved roughly 70% efficacy in the bio boxes. Next, the researchers set up the HOD UV at 100 millijoules per centimeter squared and achieved 100% settlement control. They elected to reduce the energy in the HOD chamber to optimize energy and performance. As they dropped the energy from 100 millijoules, 80 millijoules, 60 millijoules, they achieved 99% control at 40 millijoules and 90% control at 20 millijoules, ultimately agreeing on 40 millijoules for design. But did the organism change and inactivate by the energy of 40 millijoules? No, the HOD UV concentrated in a section of chamber to mimic 100 millijoules. The IR technology is on both sides of the lamp. With uniform dose distribution, there is no place for the organism to hide without getting hit by the required energy or dose. The internal reflection or IR technology mimics fiber optic science. The first secret of the HOD UV success is uniform dose distribution. Every cubic centimeter of the HOD chamber has the needed energy or dose to inactivate. Traditional UV technologies are poorly designed to enhance non-uniform dose distribution. The numerous inefficient features cause dead zones. Dead zones are ineffective treatment. Let's take a closer look at the computation fluid dynamic models of several conventional UV designs. Water takes the path of least resistance and flows downhill. As we can see, several large dead zones of inaccurate energy and poor dose distribution. The third science is logic, controls, 2 sensors per lamp, and an algorithm. As water quality or flow changes, the HOD UV will modulate energy in and out of the lamp to ensure effective treatment. Numerous inefficiencies require traditional UV to have more lamps due to poor hydraulics. Further, the metal enclosures absorbs energy to cause higher capital and operating costs. Finally, the lack of controls create poor compliance. Conventional UV designs force the use of more lamps, ultimately higher maintenance. We find that one medium pressure polychromatic lamp with internal reflection technology can do more work than 5 to 7 medium pressure lamps or 16 to 20 low pressure lamps that operate in traditional UV designs. Of course, the numbers will vary depending on the application. We now unlock the secrets of the HOD UV's unique validations, successes, and awards. uniform dose distribution throughout the internal reflection chamber, and the ability to dose pace or adjust UV energy as the water quality or flow changes. With the advancement of the HOD UV, solved are the numerous issues of poor UV designs. Solved is the non-uniformity of energy distribution as well as the inability to dose pace that created dead zones of ineffective treatment. Finally, the weak monitoring and high maintenance exacerbates poor reliability. If you would like application briefs or case studies that are specific to an application or market, please reach out to me by phone or email.
Thank you for watching my video.